NASA has released more photos from the world's most powerful telescope, revealing the deep secrets of...
Astronomers have confirmed an interstellar object is zipping through our solar system, and the story only gets weirder from there. Believed to be a comet, the object, called 3I Atlas...
The James Webb Space Telescope has once again shifted the boundaries of our understanding, this time by turning its infrared eyes toward an interstellar visitor that has raised far more concern than scientists anticipated. The object in question, cataloged as 3I/Atlas, is only the third confirmed interstellar object to pass through our solar system. Its trajectory and unusual properties already marked it as something extraordinary, but Webb's recent observations revealed details that suggest it may pose far greater risks than originally believed. Unlike most comets and asteroids that can be tracked and studied as part of the solar system's native population, interstellar objects arrive unannounced with speeds and paths shaped by distant stellar systems, leaving little time for preparation or mitigation. Before we start, smash the like and subscribe buttons for more updates. From the first detection, 3I/Atlas appeared odd. It exhibited a strange coma, a faint atmosphere of dust and gas, but its composition defied the familiar patterns astronomers expected. Initially, its unusual glow was thought to result from standard cometary activity under solar heating. However, Webb's high-resolution infrared spectrographs revealed far more volatile compounds and structural instability than anyone had projected. The telescope's sensitivity allowed scientists to study not only the surface outgassing, but also the density and fragmentation of the object's core. What emerged was a troubling picture. 3I/Atlas is shedding mass at a rate inconsistent with stable travel. This suggests that chunks of material are breaking loose, potentially creating dangerous fragments on unpredictable trajectories. What makes this particularly unsettling is the object's inbound velocity and orientation relative to the inner solar system. Its hyperbolic trajectory guarantees that it will not remain bound to the sun's gravity, but while it is here, it slices across the orbital paths of several major planets. The chance of a direct collision with Earth remains low, but the debris field it produces introduces risks of secondary impacts. Even small fragments, traveling at tens of kilometers per second, could release energy on impact equivalent to nuclear-scale detonations. The fact that Webb identified multiple fractures across its nucleus raises alarms about the potential for it to splinter further as it approaches perihelion. The James Webb Telescope's data also provided unprecedented insight into the chemical makeup of this visitor. Unlike the mostly water, ice, and dust mixtures found in solar system comets, 3I/Atlas contains exotic compounds that suggest it formed under radically different stellar conditions. Spectral signatures indicate traces of frozen carbon monoxide, cyanides, and even more complex organics that rarely survive in the outer solar system. Such volatility means the object responds more violently to solar radiation than native comets, producing asymmetric jets of material that alter its course unpredictably. These outgassing events not only destabilize its path, but also add uncertainty to trajectory predictions, making it harder to forecast whether fragments could pose a threat to Earth or nearby spacecraft. The broader implication of Webb's findings is that interstellar objects may not be the inert, harmless wanderers many assumed. Instead, they could represent high-speed delivery systems for hazardous material, carrying volatile ices and dangerous trajectories through planetary neighborhoods. This recognition is forcing astronomers to rethink planetary defense strategies. Previously, efforts were focused on cataloging and deflecting asteroids and comets bound within the solar system. But interstellar objects like 3I/Atlas present challenges of speed, unpredictability, and rarity that strain existing detection and mitigation systems. Their arrival cannot be forecast years in advance, and their high velocities reduce the time window for intervention. The James Webb data also stirs unease about the frequency of such interstellar encounters. If 3I/Atlas is already the third confirmed interstellar object in just a few years, it suggests that our solar system may be regularly pierced by such wanderers. For billions of years, Earth has likely been exposed to such visits, but without instruments like Webb, their presence went unnoticed. This raises the possibility that past catastrophic impacts, perhaps linked to mass extinctions, could have been triggered by interstellar debris rather than local solar system bodies. Understanding these patterns now becomes critical, as the potential consequences of underestimating one of these travelers could be devastating on a planetary scale. Beyond the immediate danger, 3I/Atlas opens a window into cosmic chemistry that hints at both promise and peril. Its complex molecular makeup suggests that interstellar comets could transport prebiotic ingredients across stellar boundaries, seeding worlds with the building blocks of life. But at the same time, their chaotic structures and fragility make them cosmic wildcards, capable of disintegration that floods the solar system with hazardous fragments. Webb's ability to distinguish these molecules in detail allows scientists to model scenarios of both creation and destruction, painting a picture of the dual role interstellar visitors might play in shaping life and threatening it. What intensifies the sense of urgency is how 3I/Atlas appears to behave differently from the first two interstellar visitors, Oumuamua and 2I/Borisov. While those objects sparked intrigue and debate, neither carried the immediate sense of instability that 3I/Atlas now exhibits. Oumuamua confounded astronomers with its non-gravitational acceleration and peculiar shape, while Borisov behaved more like a traditional comet. In contrast, 3I/Atlas combines high instability with high volatility, making it not only scientifically unique but also practically hazardous. Its unpredictable jets and fragmenting core render it less of a passive traveler and more of an active risk during its solar system passage. The James Webb Telescope's confirmation that 3I/Atlas is more dangerous than previously thought has ignited conversations about the preparedness of humanity for such encounters. Even though planetary defense programs like NASA's DART mission have demonstrated the ability to alter asteroid trajectories, applying similar methods to a fast-moving, fragmenting interstellar object remains untested. The speed at which 3I/Atlas travels would require detection and response far earlier than is currently possible. Webb's findings highlight a gap between our current defense strategies and the reality of interstellar threats, underscoring the need for more rapid response observation networks and advanced mitigation technologies. Another unsettling implication of Webb's findings is the realization that interstellar objects may not only threaten Earth directly but could also compromise satellites and deep space missions. Even small, untracked fragments from 3I/Atlas could pose severe risks to spacecraft. With human exploration efforts extending to the Moon, Mars, and beyond, the hazards of high-velocity debris become more pressing. Protecting both robotic and human missions from these threats will require international coordination and a reevaluation of how spacefaring nations prepare for cosmic hazards beyond the traditional asteroid and comet models. The revelations about 3I/Atlas also deepen philosophical and existential questions about our place in the galaxy. These visitors are messengers from other star systems, carrying the signatures of alien environments and histories billions of years old. They remind us that our solar system is not isolated, but part of a dynamic galactic ecosystem where material is exchanged across incomprehensible distances. Yet they also remind us that the galaxy can be hostile, delivering not just potential seeds of life, but also catastrophic threats. Webb's confirmation that such objects can be more volatile and dangerous than assumed forces humanity to recognize that cosmic hazards are not limited to local origins. The timing of Webb's observations also reveals the extraordinary advantage humanity gains from having such a powerful observatory. Without its sensitivity to faint infrared signatures, the details about 3I/Atlas would have remained invisible. Ground-based telescopes, hampered by atmospheric interference, would not have detected the faint molecular lines or the subtle thermal signatures of fracturing material. This underscores the vital role space-based observatories will continue to play in planetary defense and the study of interstellar phenomena. With Webb's discoveries, it becomes increasingly clear that future missions will need to complement its capabilities with dedicated detection systems designed specifically for early warnings about interstellar intruders. 3I/Atlas stands as both a scientific gift and a warning. It carries within it the chemistry of another world, offering clues about the diversity of planetary systems beyond our own. Yet it also demonstrates the instability and danger that such objects can bring. The James Webb Telescope's findings turn what was once a distant curiosity into a pressing reminder of the risks lurking in the darkness between stars. Each observation sharpens the urgency of preparing for a universe that is far less predictable and far more dynamic than once imagined. Webb has shown that 3I/Atlas is not simply another interstellar visitor, but a volatile, unstable traveler whose unpredictable behavior could unleash hazardous consequences. The telescope's infrared vision peeled back layers of mystery, only to reveal new layers of concern. While the object will eventually leave our solar system, the knowledge gained from its passage will shape how humanity perceives and prepares for interstellar threats in the future. It has forced a redefinition of what such visitors represent, not just scientific novelties, but potential dangers moving at cosmic speeds through the neighborhoods of planets. What Webb has confirmed changes the landscape of both astronomy and planetary defense. 3I/Atlas is more dangerous than expected, not because it is guaranteed to collide, but because it embodies a new category of cosmic risk: fast, volatile, and unpredictable. Its very presence is a challenge, compelling humanity to adapt its strategies and technologies for a future where interstellar visitors may become more common, and where the line between discovery and danger is far thinner than once assumed. The discovery that 3I/Atlas carries with it a level of volatility and unpredictability greater than any previously recorded interstellar object has pushed astronomers into entirely new territory. The James Webb Space Telescope did more than confirm its dangerous characteristics. It unveiled a profound shift in how humanity must now think about the galaxy beyond. Once interstellar visitors were regarded as benign scientific opportunities, rare jewels from distant systems that passed through our skies and offered a fleeting glimpse into alien worlds. That view has been reshaped into something more sobering. The latest findings demand a careful consideration of what such objects mean not only for our safety, but also for our long-term role as a civilization existing within an interconnected galaxy. The very fact that 3I/Atlas carries volatile compounds that interact with solar energy in ways unseen in local comets is a revelation. Its unpredictable outbursts show us that interstellar debris cannot be neatly compared to the objects we have tracked for centuries. Each one may carry its own unique fingerprint from the environment in which it formed. For astronomers, this creates both opportunity and challenge. Opportunity comes from the fact that by studying the molecular and mineral structures within such objects, humanity can trace the conditions of faraway stellar nurseries. But the challenge arises from the recognition that such exotic makeups may lead to reactions under solar heating that no existing model can predict. The consequence is simple but profound. Every new interstellar object could be a new kind of hazard. In looking at 3I/Atlas, Webb has shown us a portrait of instability writ large across a nucleus riddled with fractures and volatile pockets. Each fracture acts as a channel for outgassing, releasing streams of gas and dust that alter the object's momentum. This phenomenon is not new. Comets in our solar system have long been known to change course as jets of vapor push them in unexpected directions. But at the velocity of an interstellar traveler, these jets can redirect fragments across astronomical units of distance within weeks. The capacity for sudden shifts magnifies the difficulty of forecasting where debris will go, and thus multiplies the potential danger to Earth and its near-space environment. Perhaps most troubling is the recognition that humanity's current observation networks are inadequate for dealing with such visitors. While telescopes on Earth can spot interstellar objects, they often detect them only once they are already passing through the solar system, leaving scant time to study their paths or to prepare defensive strategies. Webb's contribution underscores the importance of having instruments capable of detecting molecular and structural instability quickly, but Webb itself cannot continuously monitor every corner of the sky. This limitation forces a question of resource allocation. How much should be invested in a system designed specifically to catch interstellar intruders before they get close enough to be dangerous? 3I/Atlas also demands attention because of its potential role in delivering cosmic material to planetary environments. While much has been said about the possibility of interstellar comets seeding worlds with organic compounds, the other side of this coin is the possibility of contamination or destabilization. Exotic compounds could interact with planetary atmospheres in unpredictable ways if even small fragments entered at high speed. For Earth, with its fragile web of ecological systems, the introduction of alien materials could pose biochemical risks. Even if such risks remain hypothetical, Webb's detailed chemical readings prove that the diversity of molecules in interstellar objects is greater than assumed, opening the door to scenarios where foreign chemistry might collide with terrestrial systems. The scientific community has been left wrestling with the philosophical implications of Webb's discovery. If 3I/Atlas is more dangerous than thought, it is not only a warning about the physical risks of interstellar debris, but also a reminder of humanity's vulnerability in the cosmic theater. Civilization has reached a stage where its technologies allow unprecedented awareness of these threats, yet the scale of what lies beyond dwarfs our ability to control it. For millennia, humanity looked at the stars and imagined them as distant and separate. Now, with Webb's infrared eyes, it becomes clear that the galaxy is not a distant backdrop, but an active environment in which our planet is immersed. Another dimension revealed by 3I/Atlas is the problem of timing. Interstellar visitors travel at extraordinary speeds, often tens of kilometers per second relative to the Sun. This makes them fast-moving targets that can only be studied during brief windows. By the time Webb secured its detailed data, the object was already making its closest approach, meaning the opportunity to study it in detail was fleeting. This fleeting nature adds urgency to the development of protocols for rapid response. If astronomers must wait weeks for data analysis, the window to predict or mitigate potential risks may close. The case of 3I/Atlas is therefore not just about the danger of the object itself, but also about the limitations of our response framework. There is also the consideration of scale. The fragments breaking off 3I/Atlas may be relatively small compared to planetary bodies, but size is deceptive when high velocity is involved. Even an object the size of a car, if traveling at interstellar speeds, would unleash the energy equivalent of several megatons upon atmospheric entry. If Webb's observations prove correct that the nucleus is shedding mass, then Earth must contend not only with a single body passing harmlessly by, but with a cloud of shrapnel capable of devastating impacts. The comparison with known meteor showers provides a useful contrast. While most meteor showers result in harmless streaks of light, they are caused by stable, predictable debris trails. Interstellar debris clouds, on the other hand, are chaotic, untracked, and potentially lethal. One of the more surprising revelations from Webb's study is the temperature distribution across 3I/Atlas's surface. Data show that it does not heat uniformly as it absorbs sunlight. Instead, certain areas erupt violently while others remain stable, creating asymmetrical outbursts. These thermal hotspots suggest internal variations in composition, with some regions containing more volatile ices than others. The implications extend beyond 3I/Atlas itself. If interstellar objects generally carry such uneven makeups, then models predicting their stability will always be uncertain. This discovery may force a rethinking of how scientists classify such objects, not as singular bodies, but as patchwork conglomerates of materials gathered across stellar environments. From a cultural perspective, Webb's findings have begun reshaping the narrative of humanity's place in space. For centuries, comets were regarded with awe and fear, often interpreted as omens of disaster. In modern times, they became objects of curiosity, symbols of cosmic wonder. Now, with the reality of 3I/Atlas's instability, that ancient sense of unease returns in a new, scientifically grounded form. The cosmos, long romanticized as distant and beautiful, is revealed as a landscape of both marvel and menace. This duality has a powerful impact on the collective imagination, influencing how societies might frame space exploration and planetary defense in the coming decades. Webb's observations also invite deeper examination of how interstellar bodies may influence the long-term evolution of planetary systems. In their journeys across the galaxy, such objects may act as agents of both destruction and transformation. They may deliver water and organics to barren worlds, sparking new possibilities for life while simultaneously posing risks of catastrophic impact. The confirmation that 3I/Atlas is dangerously unstable highlights this duality with striking clarity. It is both a messenger of life's ingredients and a harbinger of destruction, a paradox that forces humanity to view such cosmic visitors with both hope and caution. The discovery's timing is significant in another respect. Humanity stands at a threshold of interplanetary exploration. Missions to Mars, the Moon, and beyond are no longer speculative dreams, but real undertakings with serious international investment. Against this backdrop, Webb's findings serve as a warning that space is not simply an open highway awaiting colonization. It is an arena filled with dynamic hazards that could jeopardize exploration efforts if not accounted for. The risk posed by 3I/Atlas fragments to satellites and spacecraft highlights the need for incorporating planetary defense into exploration architecture from the outset. Ignoring these risks would be akin to setting sail across an ocean without preparing for storms. Moreover, the scientific challenges presented by 3I/Atlas reveal the limitations of existing models of celestial dynamics. Trajectory predictions rely heavily on gravitational calculations, but non-gravitational forces such as asymmetric outgassing complicate these forecasts. Webb's ability to detect subtle shifts in momentum from gas jets underscores how incomplete previous models were. This realization could drive new investments in computational approaches capable of integrating volatile behavior into predictive frameworks. Such progress would be essential not only for academic curiosity, but also for survival, as accurate forecasts form the backbone of any defense strategy. In contemplating 3I/Atlas, humanity is also confronted with the broader scale of galactic movement. Interstellar objects are not anomalies. They are likely abundant. The detritus of stellar systems flung into interstellar space by gravitational interactions. Webb's discovery therefore forces the realization that our solar system is not a quiet haven, but a thoroughfare in a bustling galaxy. The implications are sobering. If 3I/Atlas is more dangerous than expected, then other, perhaps larger interstellar bodies could one day cross paths with Earth. The rarity once assumed may not hold, and the perception of risk must be recalibrated accordingly. Another layer of complexity lies in the way humanity responds to knowledge of such threats. With Webb's data now public, the conversation extends beyond scientific circles into the realms of policy, defense, and philosophy. How should governments prioritize resources for planetary defense when threats are both rare and unpredictable? What role should international cooperation play when the risks of interstellar objects extend to the entire globe? Webb's confirmation of 3I/Atlas's volatility compels humanity to confront these questions directly, with the understanding that inaction could carry unimaginable consequences. The findings also provide fertile ground for future missions. If Webb has revealed the instability of 3I/Atlas from afar, then direct missions to interstellar objects could provide even deeper insights. Concepts for fast response probes capable of intercepting such bodies may move from theory into practical planning. Such missions would not only enhance scientific understanding, but also provide the data needed to develop mitigation strategies. For example, analyzing the structural composition of fragments could reveal whether deflection is possible, or whether fragmentation would only worsen the threat. The Webb telescope has provided the warning. The next step may involve sending spacecraft to meet these cosmic wanderers face to face. In reflecting on 3I/Atlas, it becomes clear that its danger lies not only in physical instability, but in what it represents about humanity's vulnerability. Our civilization thrives in a planetary system shielded by atmosphere and magnetic field, but beyond lies a universe filled with unpredictable travelers. Webb has shown us that some of these travelers are not the benign curiosities we once thought, but volatile forces carrying both creation and destruction. This recognition does not diminish the wonder of discovery. Rather, it intensifies it. For in these encounters, humanity glimpses both the fragility of its existence and the resilience required to endure. What Webb has confirmed about 3I/Atlas will ripple through science, policy, and culture for decades. It is a revelation that interstellar objects must be treated with seriousness, as potential threats as well as opportunities. It is a reminder that the universe is not static, but dynamic and often dangerous. And it is an invitation for humanity to rise to the challenge, to meet the cosmos not only with curiosity, but with vigilance. The story of 3I/Atlas is far from over, but already it has reshaped our understanding of what it means to live in a galaxy filled with wandering stars, and the fragments they cast adrift. The James Webb Space Telescope's confirmation that 3I/Atlas is significantly more dangerous than scientists had expected has opened new horizons of inquiry that extend far beyond astronomy. It compels us to examine not just the object itself, but the frameworks through which humanity perceives, responds to, and prepares for cosmic hazards. This interstellar traveler has become more than a scientific anomaly. It is a case study in how fragile Earth's security truly is when viewed in the context of a bustling, chaotic galaxy. The physics of interstellar velocities adds another layer of difficulty. 3I/Atlas, like its predecessors Oumuamua and Borisov, travels at a speed far greater than anything we associate with typical solar system comets. This means that even if a collision course were somehow identified, humanity's existing propulsion technology would struggle to mount a timely response. A deflection mission that takes months to prepare could prove irrelevant if the object spends only weeks or even days within striking distance. This urgency calls for a dramatic rethinking of how planetary defense is structured. Instead of reactive missions launched in response to detected threats, the future may demand a constant state of readiness, with interceptors pre-positioned and rapid response strategies rehearsed in advance. Webb's discovery also presses the question of scale. If 3I/Atlas represents one category of interstellar object, unstable, fragmenting, volatile, then what other categories might exist? Could there be larger, darker, more massive visitors that slip past our current detection systems? Astronomers already acknowledge that Earth's asteroid detection network is far from complete, with many mid-sized asteroids still untracked. If local objects elude our gaze, the possibility that vast interstellar masses could arrive unannounced becomes a chilling prospect. The danger lies not only in known visitors, but in the sheer unknown of what else may be moving silently through interstellar space. Beyond the scientific and defensive considerations, Webb's revelations also touch on broader philosophical issues. 3I/Atlas reminds humanity of its profound vulnerability in a cosmos that operates on scales far beyond human control. Civilization often imagines itself as master of its environment, bending Earth to its will through technology and engineering. Yet in the presence of an interstellar traveler, that sense of control evaporates. The forces at play are immense, the timelines impossibly short, the stakes nothing less than planetary survival. This recognition is both humbling and motivating, offering a stark reminder that space exploration is not a luxury, but a necessity for understanding and safeguarding our place in the universe. The cultural impact of Webb's findings is already beginning to take shape. Media narratives surrounding 3I/Atlas have emphasized its volatility and danger, sparking a resurgence of public interest in planetary defense. This growing awareness may fuel political momentum for funding advanced detection systems and mitigation technologies. In a sense, interstellar objects may serve as unintentional catalysts for humanity's expansion of its defensive capabilities. Much as comets in ancient times were seen as omens that shaped human behavior, so too do modern interstellar visitors now drive societies toward new investments in science and technology. The difference is that today those responses can be grounded not in superstition, but in data gleaned from the most advanced telescope ever built. Webb's confirmation also provokes new discussions about the interconnectedness of galactic systems. 3I/Atlas did not originate here. It is a fragment of another world torn from its home star system and flung into interstellar space. Its presence within our solar system is a reminder that the galaxy is dynamic, with material constantly exchanged between stars. This exchange may be responsible for seeding life across vast distances, carrying organic molecules to otherwise barren planets. Yet it may also spread hazards, distributing volatile, unstable bodies that can disrupt planetary systems they encounter. The duality of interstellar exchange, both creative and destructive, is one of the most striking implications of Webb's work. On the technical side, Webb's role in analyzing 3I/Atlas also showcases the necessity of advanced space-based observatories for planetary defense. Infrared spectroscopy revealed the object's volatile compounds and structural weaknesses, information that ground-based observatories could never have gathered with comparable precision. This success strengthens the argument for building more telescopes designed explicitly for detection and analysis of near-Earth and interstellar objects. The case for investment is no longer limited to scientific curiosity. It is a matter of survival. Humanity now has proof that some interstellar visitors may be more unstable and hazardous than imagined. That knowledge alone compels action. There are also implications for human exploration beyond Earth. As missions venture farther into space, toward the Moon, Mars, and eventually beyond, the hazards posed by high-velocity debris from interstellar objects become more pressing. Satellites, space stations, and exploratory spacecraft are far more vulnerable than Earth's surface, lacking the shield of a thick atmosphere. A single fragment from 3I/Atlas could disable or destroy a spacecraft with catastrophic consequences. This risk must be factored into the planning of future missions, shaping everything from trajectory design to shielding technology. In this way, Webb's discoveries ripple outward to affect not only Earth's safety, but the viability of our broader spacefaring ambitions. Another dimension worth considering is how these findings influence international relations. Interstellar objects do not respect national borders. Their risks are global in nature. This means that planetary defense against such hazards must be a cooperative endeavor requiring data sharing, coordinated observation networks, and potentially joint mitigation missions. Webb's revelations about 3I/Atlas underscore the urgency of developing global frameworks for responding to interstellar threats. Unlike many geopolitical issues, this is one where cooperation is not optional. It is existential. If even small fragments from such an object threaten widespread damage, no single nation can shield itself in isolation. From an educational perspective, the study of 3I/Atlas may also reshape how astronomy is taught and understood. For decades, interstellar space was portrayed as vast and empty, with little more than tenuous gas clouds between the stars. The discovery of multiple interstellar visitors within a short span of years, and now the confirmation of their instability, redefines that perception. Students of astronomy will no longer think of interstellar space as void, but as a bustling arena where fragments of distant worlds travel across light years. This shift in perspective may inspire new generations of scientists to focus on planetary defense, astrophysics, and interstellar chemistry. The psychological impact of Webb's discoveries is equally fascinating. Humanity has always grappled with existential threats, from natural disasters to pandemics. But cosmic threats occupy a unique place in the imagination. They are reminders of forces so immense and impersonal that they dwarf human concerns. The knowledge that an interstellar object like 3I/Atlas can fragment unpredictably and unleash high-speed debris rekindles a sense of vulnerability that modern life often obscures. This vulnerability, however, need not lead to despair. It can serve as a call to action, inspiring resilience and innovation. The challenge lies in channeling awareness into constructive efforts rather than paralyzing fear. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on James Webb's findings about 3I/Atlas being dangerous? We want to hear from you. Thank you for watching and see you next time.